Alright guys, last lesson! Woo! You've almost survived discrete math. This is the last lesson. Today we're going to be looking at solving linear inequalities. Okay, again, this is review from Math 1. So, remember that when you have a linear equality and two variables, it can be in one of the following forms. It can be greater than or equal to. It can be greater than. It can be less than or equal to, or it can be less than. Okay, and to solve, to find the solutions of an inequality, you find any ordered pair that makes the statement true. And unlike a system of equations, it can have multiple pieces, because remember it says less than or equal to. Well, there's a bunch of numbers that are less than or equal to, or less than, or what have you. So what we're going to do here for this inequality here is we're going to see which of these ordered pairs are solutions to this inequality. Now, remember the symbol is less than or equal to. Okay, so what we're going to do is we're going to go through and we're going to plug these in for x and y. Plug in values for x and y. Alright, so let's see if A works. So we're going to do 2 times 2 plus 3 times 3 and see if it's less than or equal to 6. So this is 4 plus 9. So that gives me 13. 13 is not less than or equal to 6. So that one doesn't work. So let's go to the next ordered pair. 2 times 0 plus 3 times 2. We want to know, is that less than or equal to 6? And it's equal to 6, so this is a true statement. So that one works. Alright, let's go to the next one. 2 times negative 4 plus 3 times 3. Is that less than or equal to 6? So that's negative 8 plus 9 is less than or equal to 6. So that's 1. It's less than or equal to 6. So this is a yes. So C also works. Alright, let's do D. 2 times 5 plus 3 times 2 is less than 6. So this is 10 plus 6. No, this isn't going to work. This is 16. So that one's not going to work. Alright, let's do E. So we have 2 times 2 plus 3 times negative 4. We want to know, is that less than 6? So this is 4 plus negative 12, which is negative 8, which is less than or equal to 6. So this one does work. Okay, so I want you to pause this, and I want you to go ahead and plug these in and see which ones you find on the bottom row that work. And then unmute it and we'll come back together. Okay, welcome back. So on the bottom row, F does work. H does work. And J does work. Okay? And that's the way that happens. Okay? So good times there. Give me just a second to get to this. Now, systems of inequalities. How do we find that? Because with systems of equations, you find where they overlap. But if they're inequalities, how do you even graph an inequality? Okay, so a solution set for a linear inequality into two variables, we're going to do that first, and then we'll look at the systems. So the solution set for a linear inequality in two variables is always a half plane with either a solid or dotted border. Okay, so I am going to simplify all this. Okay, so if you have these symbols, it's going to be a solid line. If you have these symbols, it's going to be a dotted line. Okay, so what all of this means down here, as long as your y is on your left. So if your y is on the left, so just always make sure your y is on the left like we normally do anyway. If you have a less or less than or equal to, you're going to shade below. If you have a greater than or equal to, you're going to shade above. Now, that shading tells you all the ordered pairs that work for that equation. Now, if you have a solid line, then the points on that line also are part of the solution. If it's a dotted line, then those points are not. It's kind of like the way an asymptote does. It's not part. Okay? So, the first thing we're going to do is we're going to get y by itself. Okay, so we're going to move the 4x over, so we have negative 3y is greater than or equal to negative 4x plus 9. Now, what we're going to do here is divide both pieces by negative 3. Please remember when you have a negative y, like this is a negative 3y, so a negative y value, flip the inequality. Okay, so this is going to be y is less than or equal to positive 4/3 minus x minus 3. Okay, now step 2, remember how to graph. Pull out slope and y-intercept. So our m is 4/3 and b is negative 3. Okay? Plot b value on y-axis, then use slope, rise over run to get second point. Okay, so our y-intercept is -3, so we plot that on the y-axis. Then our slope is positive 4/3, so that means we go up 4, 1, 2, 3, 4, and we go to the right 3. And that's how we get our 2 points. Now, this symbol was a less than or equal to, so that's going to be a solid line, and it's less than, so we shade below, because when we flip that symbol. Okay, so this is going to be a solid line. Let me get my ruler here. And we shade below. So all these points from this line and below, if you pick any of those ordered pairs, it would make this inequality true. Okay? Awesome. Now, to do systems of equations, you're just going to graph both lines, shade them, and where they overlap, that is our solution. So we solve the inequality separately, find the intersection of the individual solution sets. Okay. So, let's do the first one. 2x minus 3y is less than -6. So we move our 2x over by subtraction. Now we're going to divide everything by -3, and it was a negative, so we flip it. So this is now positive 2/3 x plus 2. This is m equals 2/3, b equals 2. So we go to 2, 1, 2. We go up 2. Now if this was a negative 2/3, you go down 2 and still write 3. But this is positive 2/3, so go up 2, right 3. Now we have this symbol, so this means it's going to be a dotted line, and shade above. And remember, when it's a dotted line, that the points that are on that line do not count as part of the solution. It's kind of like a boundary line, but it doesn't count. Okay, so we're going to shade above. Okay, so we got all those. Now, let's do this one in red. Okay, so we have x plus y is less than or equal to 7. Move the x over, and we don't even have to divide anything. So our m is -1. Remember, we like it as a fraction, so you can put a 1 underneath it. Our b is 7. Now, our symbol was less than or equal to. This is a solid line because it has the equal to, and this is shade below because it's less than. Okay, so we're going to go to 7. 1, 2, 3, 4, 5, 6, 7. And it says -1, so go down 1, right 1. And this is going to be a solid line. When you try to draw your lines, try to make it go to the end of each of your graphs so you can shade appropriately. And this one says shade below. So our overlap, if you wanted to get another color, I'm going to get black here. The overlap is the part that is the actual answer. So this section right up here is your answer. Okay? Now, let's do modeling with systems of inequalities. Last problem. Harold is a marathon runner who is interested in the amount of protein and calcium in his diet. So we're going to be dealing with protein and calcium. A serving of fried shrimp contains approximately 15 grams of protein. Fried shrimp, 15 grams of protein, and the shrimp has 60 milligrams of calcium. Okay, a spear of broccoli contains 5 grams of protein and 80 milligrams of calcium. Assume that as part of his diet he wants to get at least 60 grams of protein and 600 milligrams of calcium. So at least that. Okay, so we're going to let the two things that we're looking at here, we're going to let the fried shrimp be S, which would be our X. So let's just make it an X. Okay. We're going to let fried shrimp be our X and broccoli be our Y. Alright, so we're going to make an equation for protein and one for calcium. So protein, 15x plus 5y, and at least that means he wants that or more, so greater than or equal to 60. So for calcium, 60x plus 80y is greater than or equal to 600. Okay, so now we just saw both of these and graph them. Alright, so I'm going to do this one first. So 15x plus 5y is greater than 60. So we're going to move the 15 over by subtraction. Then we're going to divide both pieces by 5. That was positive, so we don't need to flip anything. So negative 3x plus 12. M is negative 3 over 1. Because remember, we need it to be a fraction. And B is 12. And this is a greater than or equal to, so this is solid and shade above. Alright, so let's see what we can do with this. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Let's just go right about here for 12. Okay, then we're going to go down 3. So we go down 2, 3, 1. Okay. I don't know why they didn't make your graph big enough. Okay, so here it's solid, we said. Okay. And we shade above. Okay. So we have that. Now let's do the other one. 60x plus 80y is greater than or equal to 600. So we have 80y. We're going to move the 60 over. We're going to divide by 80. So y is greater than or equal to negative 3/4. It gives you 0.75, but you need that as a fraction. Sorry about that. You couldn't see any of that, could you? Plus, and you can make this a decimal or whatever you need it to be. So 7.5. So m is negative 3/4. I normally don't like to put fractions and decimals in the same equation, but I'll forgive it this time. And this is greater than or equal to, so it's solid. And shade above. Alright, so let's see what we got here. So 1, 2, 3, 4, 5, 6, 7.5. And then we're going to drop down 3. So 1, 2, 3, 4. 1, 2, 3, 4. Okay. And then okay. So the overlap would be right here. So that means that if he wants to eat that amount of calcium, then if he ate 1, 2, 3 servings of shrimp and 1, 2, 3, 4, 5, 6 servings of broccoli, he would get there. Or he could eat more servings of shrimp and less servings of broccoli, whichever way he wanted to do it. But that's how you could figure that out. Okay? If you need to watch any of that or pause it to get this copy down or anything, feel free. If you have any questions, let me know. Guys, you've survived all of my teaching of my lessons. Have a great day.